Good afternoon, this is seraph.millar, and this is our Advanced Concepts, the Penny Lab. So in this lab, we are going to take salt and vinegar and mix it in a bowl until the salt dissolves, and we're going to put our pennies in. So hopefully when we put our pennies in, the copper oxide is going to dissolve in the vinegar. And if we take them out and put them in water, it's going to stop the chemical reaction, where if we leave them on paper or a paper towel afterwards, it should allow the chemical reaction to continue, adding oxygen to that chemical reaction, which should form some malachite for us. So we're going to do our vinegar, 1/4 cup, and 1 teaspoon of salt. I actually doubled this equation because I have a piece of copper pipe from work that is kind of dirty. So hopefully we can make it shiny again when we put it in there. So we're going to mix it up with our plastic spoon, not our metal, till the salt dissolves. And what I'm going to do, just to see, I have my nifty little paintbrush here, we're going to put a little bit on one of these pennies and just let it. So we're going to put a little bit just on one of these little pennies. And oh, it's coming off already. That's dirty. Hopefully we'll have just one clean spot inside of it compared to everybody else. Let it sit there. Okay, so now we're going to take our other pennies, our nice dirty pennies, and put them in our mix. This one I also did bubbles on, and we're waiting to see how old that guy is. So while we wait for those, this is my plastic fork. Oh my gosh, they change so fast. The water's cloudy already. So what we already have learned is that vinegar and salt is our acetate acid and sodium chloride. And when we put the dirty penny in there, that dirty penny is covered with copper oxide. The copper oxide should go into the solution, and then when we rinse that penny in water, which is H2O, it should stop the reaction. So why does this happen? When we put the penny in the water, the penny gives off its positive protons into the solution as our copper ions, and then when we take the penny out, they're all still floating in that solution. Then when we put our bolt nail in there, it should suck up those positive ions to it, changing the color of this guy when we're done. So what we're going to do is we're going to add that copper ring. So we have our nice dirty copper ring also. And we're going to put him in there. And now we wait. Well, putting it on top didn't really change it much, so let's throw it in and see what that one started to. Maybe I didn't wait long enough, but we're going to put it in anyway. So we are waiting on these guys, and I have one penny giving off enormous amounts of bubbles compared to the rest of them. So think about, like when we have dirty pennies, it is because all that dirt is covered with the copper oxide, and that copper oxide is being released into the solution with the gas. And I'm pretty sure my older pennies are giving off more bubbles than the rest of them. Maybe because the older pennies have more copper in them and our current pennies are just zinc plated in copper. But look at the difference between our actual copper pipe and the pennies. We're going to give that a few more minutes since there's still so many bubbles coming off of that guy. It's actually pretty cool that you can see, almost like watching the ions move through the solution as they break apart. So while we're waiting, I do sheet metal, and when we do architectural sheet metal, we use copper on sorry. We do copper roofs and cupolas. And when we do the copper, for some reason, usually the general contractor wants that green tint on the copper. They want that malachite to be there. So what we end up doing is after we install it, spots that need to be sealed have flux on them, and then we actually burn them with, we bring up propane gas and we burn all the copper, and it makes it turn greener faster. Maybe because it's burning off the coating that the copper comes with. That way the copper is exposed more instead of just the coating that's protecting the copper from being oxidized. But that's a part of what we do, and regularly we have to oxidize the copper that we use. Okay, so this is our time lapse. So we waited 20 minutes, and now we're going to put some water in the other bowl to stop some of the reactions. Definitely the copper ring. And some of these copper pennies, well, kind of copper pennies. They don't look that clean, guys. And then we're going to put some on the paper towel. I'll leave the dirty one in there. It needs to sit longer. And let them react with the oxygen and see what happens to them. Woo! Runaway penny. So the ones we put in the water stopped their chemical reaction, although that's really not the best copper, because if I take and at work we have some steel wool, and you can see the difference between, where is it? Let me flip it around for you. Where I cleaned and where I didn't. So it did clean, just not as well as we thought it would. Maybe my vinegar's old. I don't know. But, and then we have our pennies that we stopped. And they don't look so bad. They probably need to sit for a lot longer. But this one, we definitely got the most change. That guy is still bubbling crazy. And these ones we're going to let sit out and watch them turn green. And we'll be back in a few hours. So that's our presentation. Hopefully we'll get some green pennies and I can attach the pictures at the end. Otherwise, we're going to let that one continue to bubble and see what happens.